Hi there everyone, welcome back to the channel. I'm the GCSE Science teacher. In today's video, we're going to be learning about waves, specifically focusing on the required practical, where we look at different wave characteristics and the maths and methods associated with this practical for how waves are transferred in a solid. Now, the previous video I did on this topic, we looked at general wave characteristics, we looked at transverse and longitudinal waves, and we also looked at waves in water, so with the experiment associated with the ripple tank. Now, that practical is a required practical that links nicely to this one. So there is quite a few differences in both of those practicals, and I would recommend you understand both, you make some flashcards on them, and hopefully that will help you understand this topic further. If you do enjoy this topic and you enjoy this video in general, let me know by giving it a thumbs up. Please also feel free to comment in the comment section below. Any video suggestions you have for me, any top tips that you have discovered along the way. Maybe you're in year 10 and you're doing your mock exams. Maybe you're in year 11 and you'd like to give some year 10s on this channel some advice, especially if you're currently doing your GCSEs now. So it's always good to hear from you guys, so feel free to do that. And if you haven't already and you would like to, please subscribe and join this amazing community. We just talk about science here and we all love science. So it's a great place to be. And thank you so much for your support. So let's talk about this practical, the aim of it, the method, what you need to know. So the aim of this practical essentially is to measure the frequency, the wavelength, and the speed of waves in a solid, such as a string. Now, the frequency of a wave essentially is how quickly those waves appear in a given time frame. The wavelength is just the length of that wave from one peak to the next peak, from one trough to the next trough. And the wave speed, as the name would suggest, is how quickly that wave travels. Remember that waves transfer energy and not matter. And just remember the units of these things. So frequency is always measured in hertz, wavelength is measured in meters, and speed is measured in meters per second. Sometimes this can be also confused with acceleration, velocity, and all those other words associated with the speed of something. Remember, velocity and speed we can refer to as the same thing. Acceleration is talking about how quickly something increases in speed, which we're not talking about today. Different unit. Acceleration is meters per second squared, whereas velocity and speed is meters per second. So don't get those two confused. Now, anyway, let's talk about the method itself. So what you want to have in terms of apparatus, the things that you'll need to do this experiment, you'll need to have what we call a vibration generator. And essentially what this is a device, an electrical device you connect to something called a signal generator. Now, the signal generator produces the frequency that we are talking about in terms of the wave frequency. And we can change this depending on the frequency we want. This is attached to the vibration generator that literally causes vibrations in that spring. And it does this at a very, very quick speed as well, and of quick frequency. And like I said, we can change that depending on the signal generator. So that's already preloaded. We don't really need to worry about frequency or measuring it. We can just see it on the device and use that data there. So what you want to do is you want to attach the string you're using to the vibration generator, and you want to place some masses at the end of the string. So a few 100 grams of masses, 250 grams, something like this. And this will keep the string really taut, because that's the way you need to do this experiment. The string needs to be nice and tight so you can see those waves that are being produced. Now, you want to place a wooden bridge under the string near the pulley, and this will help with that tautness as well. Then you want to turn the vibration generator on and adjust that wooden bridge until stationary waves are observed. Now, you have probably heard of transverse waves and longitudinal waves, but now we're talking about stationary waves, sometimes also referred to standing waves. There's loads of waves. What are we talking about here? Essentially, a stationary wave looks very unusual in the fact that you can actually see it where the waves are being produced. It looks most like a transverse wave, so that kind of typical up and down motion you would see in a wave. However, the wave itself appears to be stationary. It doesn't look like it's moving. However, it's moving so quickly that you know it obviously is moving. So you may have actually seen this in real life, in the case of, like, if any of you are musicians out there, or you like musical instruments like guitars, if you look at the string of a guitar and you were to pluck it, sometimes the string moves so quickly, it appears to make almost like a phased effect of all the little motions it makes in that process of moving back and forth. That's what we're talking about. And I'll show you an example in a moment. But essentially, that's what a stationary wave is. You won't be really expected to talk about stationary waves or how this works or the details of this idea of resonance that it comes from. I can leave some information if you're interested in the description box, but this is more of like an A-level thing. GCSE, they're not going to ask you that. But anyway, so we produce these waves, and all we need to do, the next step, is to measure across as many wavelengths as possible from the generator, from the vibration generator, all the way to the wooden bridge. You're going to measure that total length. And then we're going to be able to work out the wavelength of that wave. And I'll show you how to do this in a moment as well. After this, you want to multiply this number by 2 to calculate the wavelength. Again, I'll show you how to do this. And then you're going to put this into the wave speed equation, which essentially is wave speed equals frequency times the wavelength. And I'll give you some examples too. So that is generally the method you're going to want to use. So this is the sort of wave I'm talking about. So you can see we have this pattern appearance. Now, in terms of transverse waves, you normally just see that up and down motion. If we were to move a piece of string back and forth, back and forth, back and forth, up and down, you'll see that nice transverse wave. But because obviously we are only able to really do that with our arm back and forth, we only see a certain motion. However, if we were to use a vibration generator such as this, in this example practical, you will see that wave in that specific motion. If you get a chance to do this in school or in class and you actually see this, there are loads of videos as well on YouTube that people have actually demonstrated this. It's really cool to see. I highly recommend you just do a quick Google search and you will see that. But these are the waves that you will see, generally speaking. And all you need to do is measure along. So as you can see in this case, I have the results of the waves being shown. You can see we've got 4 half wavelengths and I've just gone across 2 of them to measure 1 full wavelength. Now I'm going to do some maths in a moment with this, but I did just want to make a point at this stage. Whenever you are doing this practical, if you are, make sure you're wearing goggles because the safety aspects to this, although they're quite low, if you are pulling that string very taut and it's vibrating, it could snap. So I would highly recommend you use thick string so you don't have that issue, but just be careful when you're doing this so you don't hurt yourself. Wear goggles, stand well back, and yeah, be safe. Okay, so here is the results that we've got. So I'm just going to make up some data to explain what you need to do. So in the case of this experiment, you would see that we have, for example, 3 half wavelengths from the vibration generator to the wooden bridge. Now, the half wavelengths you see, the wavelength is actually represented with the symbol lambda, which is a Greek letter. We talked about this last lesson, but there are symbols associated with these things. It's just worth knowing what they are. But you can see we've got 3 half wavelengths. So if we wanted to calculate the total wavelength of this wave, all we need to do is measure the entire length first of all. So we've gone from the vibration generator to the wooden bridge, those waves that are being produced. You can see, let's make up some data. Let's say it's 30 centimeters or 0.30 meters. Then you want to divide that number by the number of waves that you see in terms of half wavelengths. So we have 3 half wavelengths here, and our total distance, our total length is 30 centimeters or 0.3 meters. So we divide 0.3 meters or 30 centimeters by 3 because we have 3 half wavelengths. So 30 divided by 3 gives us 10 centimeters or 0.1 meters. We then want to multiply that number by 2 to get the full wavelength because we're talking about half wavelengths here. So you're going to do 10 centimeters or 0.1 meters times by 2, and we should get 20 centimeters or 0.2 meters. Really recommend you convert into meters so that you get the correct answer when you're talking about wavelength, because they do like you to use meters unless they specify something else. Okay, so let's have a go at this with some actual data. So remember the steps, we have them there. But essentially what you're going to do is you're going to get your ruler, you're going to measure out the total length. So in this case, we have 0.213 meters as our total length from the vibration generator to the wooden bridge. We then want to make sure that we are counting the number of half waves, and we should see that in this case, there's 3. So all we need to do is do 0.213 meters divided by 3 degree, this will give us an answer of 0.071 meters. We then times this number by 2 to get the whole wavelength of one wave, because remember, we're working in half wavelengths. So that would give us an answer of 0.142. If we times 0.071 by 2, that would be our answer there. We then want to put this information, because we now have the wavelength and we want to work out the speed of the wave. So we would use that equation we talked about before, it being speed. So V equals the frequency F times lambda, the wavelength. So we're going to do the frequency of 20 hertz times by the wavelength we just calculated as 0.142. Now, the reason we're using 20 hertz is in this situation, the frequency used to create these waves was 20 hertz. However, this could change. This could be variable. So this is just an example. And I got this information from the signal generator that's attached to the vibration generator. So you would be given this information when you do this practical. The answer we'd get would be 2.84 meters per second. Make sure you underline your answer, you use the correct units, and of course, as with anything I always say on this channel, specifically and in real life, to my students in real life as well, if you type it, you must write it. Remember, anything that goes in your calculator, evidence what you've done by writing it down as well. That's what true scientists do. We use evidence to back up what we're talking about to help strengthen our understanding and answers, and help obviously communicate to other people. That's kind of what science all is about. So anyway, that would be our answer in this case. Now over to you guys. Calculate the wave speed if we change the frequency. I will give you the answer and the workings out in the description box as always. Feel free to comment down below. It's always good to hear from you guys. And yeah, good luck with that one. So here is some exemplar data of this practical when we are looking at different wave frequencies. So we've got 5 hertz, 10 hertz, 15 hertz, and of course this can continue on. We also have the wavelength and the wave speed associated with each of those frequencies as well. And this is example data that's come from the exam board. So this is something that they clearly have done themselves and they want to share this with students and teachers. It's nice to kind of show this at this point, because a lot of the time in GCSEs, they'll give you some data and they'll ask you to essentially interpret it. It's either going to be in a table, it's going to be in a chart, it's going to be in a graph. But the more exposure you get to maths and science and data and handling data and understanding what it's showing you, the better you're going to get at essentially interpreting it in a quick way, especially when it comes to that exam. So let's just have a quick look at their data and see what it's telling us. So the wave speed, we can see as the frequency increases, we can see the wave speed actually decreases. So the waves get quicker as the frequency gets higher. The wavelength also gets shorter as the frequency gets higher, as the wave speed gets quicker as well, which is kind of what we would expect. You know, if you've got a wave that is moving faster, you'd expect the wavelengths to be much shorter to accommodate that new speed. So yeah, that data kind of would show us what we'd expect. We could hypothesize this before the practical and see if our own data shows this as well. So it's just good to see, is this what we're expecting to see? It kind of is. So that's always nice to have a look at as well. So here are my general tips for any of you who are looking to revise the required practicals and want some general help and advice with just what to know for the required practicals, what kind of things transcend across biology, chemistry, and physics, and key ideas that you should know to help you solidify your understanding and get those higher marks. So remember the variables. That's my biggest help for you. So knowing what the control variable is, the independent variable, and what the dependent variable is for that particular required practical, making a flashcard on the required practicals for biology, chemistry, and physics, but also knowing those variables will really help you understand that practical. So just as a bit of an overview, remember that control variables are something that you keep the same. So for example, if you're looking at a practical that's investigating how temperature affects enzymes, you're going to make sure the pH is controlled. So it's the same in every case. So that's because we know pH affects enzymes, right? So we want to make sure nothing else except temperature is being varied or changed. Speaking of things you're changing or altering, that would be your independent variable. So something you're looking to investigate. So in the case of the enzyme practical I just mentioned, temperature would be your change, your independent variable. And then the thing you're measuring, is what you're looking to record. So your dependent variable. So again, in the case of the enzyme practical, we want to look at how quickly an enzyme breaks down a substance, let's say starch into glucose. I don't know, something like that, right? That would be your dependent variable, how quickly that happens, your time, the time it takes. So in the case of this practical looking at waves and the specific practicals we've talked about today, we'd want to control the solid substance you're using, so the type of string. So we wouldn't want to use, say, like a really thick piece of rope and then a teeny tiny thin piece of thread. That would not be appropriate. We want to control this solid we're using. The thing you might want to alter might be the frequency, like you saw in the sampler data. That would be a good thing to do. Change the frequency, alter that, see how it affects wave speed and wavelength. The thing you're measuring, of course, is going to be the wavelength or the length in total to work out the wavelength. So you can always apply these ideas to the practical, and it's worth trying to kind of check yourself. Do you know what they mean? And therefore, can you apply what they mean to specific practical? So a way to remember this is the acronym SID-SAM. And this was kindly commented down below in a video of mine. I'll leave the person's username as a big shout out on the screen. Thank you so much. It's amazing to have you comment something so helpful for other people. So the other tip I have for you is to look at the correct equipment names. So this is not necessarily important for this practical, although I say that it kind of is. So vibration generator, it's worth knowing the name of it. But this is particularly important for things like chemistry and glassware that you're using in biology as well. So knowing the shape of a conical flask versus a beaker and why either of those would be used, or knowing that you're going to be using a vernier caliper versus a other measuring device like a ruler. It's worth being aware of what those things do. Strengthen your method and strengthen your ability in getting higher marks, because that comes on to my next point, which is the fact that when you write a method, you're actually getting marked on what we call a leveled answer. So often in science, you'll get like a question and it will be like worth 3 marks or 2 marks or 4 marks. Those are kind of low stake questions where you just need to kind of bullet point key points. And if you do that, you'll generally get the marks. However, when you get to the 6 mark questions where you're expected to write out a method or a longer answer, like a compare or evaluate question, you'll be expected to write in a certain way that will be level. To get the top level, the one that gives you the full marks, especially in a method, you need to write the answer that's logically linked. So your points are not just bullet points of keywords and key phrases, they actually link together and help explain what you're trying to discuss. And you also need, especially if it's a method, your method needs to lead to valid results. So the way I actually mention this to my students is I'll say, I want you to write a method, but I want you to imagine you're giving this method to someone in year 7. And they'll be supervised, so they're safe, but they do need to be able to do this using your method only and actually get results that are correct or valid and are going, essentially, the method should work. It's like following a recipe. We've all been there. You may have made something like a cake at home. I know I have. And you followed a recipe and someone's missed out a step and the cake doesn't go well and it's a disaster, right? It's the same with a method. If you don't clearly explain what you're doing, it doesn't always work. And that's the key to this. So you want to make sure that when you're writing in enough detail that's concise so you don't spend too much time in the exam, but so you actually get valid outcomes. And that's my best advice for you. And then lastly, any maths for science associated with practicals. So how do they assess this? For example, some of the practicals, they might ask you to draw data as a graph. They might ask you to interpret data as a graph. They might ask you to calculate the mean average. They might ask you to include data in a table or use data in a table to explain what is being shown and essentially, is the hypothesis right? What's the conclusion? So it's worth looking at past paper questions on those different practicals and just being aware of the different ways they can ask you questions. And that way you are fully informed and you know how you could be asked the questions. And that's it from me today. I've been the GCSE science teacher and you have been curious. If you did enjoy this video, feel free to give it a big thumbs up, share it with someone else so they don't miss out on key revision. And thank you so much if you've already subscribed, but if you haven't, feel free to click that subscription button. It's absolutely free and it'd be amazing to have you as part of our community. In the meantime, have a great day and I will catch you in the next one.